9. So gravel is being dumped from a conveyor belt at a rate of 30 cubic feet per minute. We stop before we continue. So where's my button? Okay, so I have to identify what this means. First, I'm given 30 cubic feet per minute. I need to identify what this is so I can continue. I will not continue reading if I don't identify what this represents.
I'm sorry, I couldn't submit it in time. They email my answer to you?
Yes. Okay, so can anyone tell us what this is? Any suggestions? What could this be? What is given to us as 30 cubic feet per minute?
So dx over dt?
Correct, but what is the top? I cannot just say everything is x. I have to think for a moment. But you're right, it's a derivative, absolutely. But of what? This is very clear. But what is the measurement unit for this? What will that represent?
So it's the derivative of the volume.
Excellent.
The change in volume. So it's, yeah, it's a change in volume. The derivative
exactly. Awesome. This measurement unit tells me what this is. This measurement unit tells me what this is. Awesome. Brilliant. Thank you. That's all I needed. Thank you very much. Okay, now we continue reading. Only now. And it says the crystal is such that it forms a pile in the shape of a cone. Okay, fine. Cone. Whose base diameter and height are always equal. Stop. Draw. Height. Diameter. Always equal. If it says always, then it has to be taken into account from the beginning. If it says when or at the instant, no. This is a trap. But if it says always, I have to take it into account from the beginning. Okay, perfect. Moving on. How fast is the height of the pile increasing? This is the trap. This is it, right here. Anything that follows after when, I know I have to forget about it till the end of the problem. So how fast is the height increasing when blah, blah, blah? The height is 10. So when the height is 10 feet. But I know that this will not be taken into account till the end. What am I asked to find? Again, let's read the last part, the question. How fast is the height of the pile increasing? So what am I asked to find here?
dHdt.
Thank you so much. That's all I needed. That's what I'm asked. How fast? It means a rate of change. Is increasing, I have to get a positive number. If it says how fast is decreasing, then I have to get a negative number. Make sure that you keep that in mind. Okay, perfect. So then, like before with that volume and the surface of the sphere, I would like you to remember the following. So this is connecting concepts or formulas if you want, in this case. We always know the, I'm looking to see if I have, I don't have a cylinder here. Okay, so let's say, imagine that this is just this, the cylinder. What is the volume of this cylinder? This is for my glasses. So what is the volume of the cylinder? Area of the base times the height. Area of the base, pi r squared, because it's a circle. So pi r squared times the height. But that's for the cylinder. area of the base times the height. What's the connection to the cone? We're talking about the cone here. Easy to remember. It's the same thing divided by 3. So the volume of the cone is 1/3 pi r squared h. So keep these two, remember them together. If you remember the volume of the cylinder, just divide by 3 and you get the volume of the cone. Now this is not relevant. I just wanted to connect them to show you how to remember them easy. Okay, so we don't need any of this. We only need the volume of the cone. Why do I have to start with the volume of the cone? Well, because that's what I'm given. I'm given the rate of change of the volume. So I have to start with the volume. That's the function that I start with. Okay, now I'm asked to find the age of a dt, and I'm told that h and d are the same, always. But anyone remembers what does the diameter of a circle equal to? Because I don't have the diameter in my formula. I have something else in my formula. So then the diameter is always equal to what?
Height.
Yes, I have it right here. What else? The diameter of a circle is always equal to?
2r.
Exactly. So keep that in mind, because I have r, and nobody tells me anything about r. So I have to replace r by h over 2 in our formula. So this has to disappear. It will be replaced by h over 2, squared, of course, which will give us h squared over 4. So the volume of the cone equals pi over 3 times h squared over 4 times h. Volume condensed further, pi over 12 h to the third. I needed to work hard, if you want, on my function. And now I am asked to find, remember, the age over dt, which means I'm going to put a little dot to help us remember that these functions are functions of what? These functions are functions of
Time.
Exactly. Awesome. Thank you. I have the equation that relates the functions of time. I want an equation that relates or connects their derivatives. No problem. What do I do?
Natural log.
No. This is not a function raised to a function. So we differentiate the left-hand side.
dv over dt.
Of course. Pi over 12 with a 3, it's pi over 4 times h squared times,
dh dt.
of course. And remember, this is what the problem is asking us. I solve for the age over dt, and then I plug in my 10 and anything else. So solving for this means dividing dv over dt by this quantity. So dh over dt equals, you cannot separate these two. This is together at the top. They are together at the top. Divided by pi over 4 times h squared. And now, yes, almost done. H is 10 and dv over dt is 30. They gave us 30 from the beginning and they told us h is 10. This is a piece of cake now because the top is 30. The denominator is pi over 4 times 10 squared, which is 100. Be very careful how you plug it in, but I recommend first simplify by 4. So you only divide 30 by 25 times pi. I'm going to share my screen. Careful how we divide. Otherwise, you need extra parentheses. It's no big deal, but be very careful how you enter it. So here we have 30 divided by, I recommend parentheses, 25 pi. I don't know how they want the answer. I didn't check. But so the answer is 0.38. Let's say 2 decimal digits. Measurement unit. 0.38 does not mean anything. So I wrote 0.38. So now, can anyone tell us what is the measurement unit? Remember, dH over dt. So age was measured in feet, time in minutes. So what is the measurement unit for? I don't want you to think that this is one here. There's one here. So let me erase that. So I have here the squiggly and the equal here, the continuing. So measurement unit. Can anyone give us the measurement unit?
Feet per minute.
Feet per minute. Awesome. That's it. Any questions on this problem? Any questions on this problem? So last time, so far, we saw 2 different types of problems. Basically, one in which we used the Pythagorean theorem. We used Pythagorean theorem in 2 problems. And this one is different. Why? Because here we have the volume of a cone to work with. So this was easier. We didn't have to create an equation. We had the formula for the volume of the cone. We only had to replace r because we have no knowledge about r. So we had to get rid of that because we needed only 2 variables, right? Two related rates. If I have the third one and I don't have any information about it, then I'll get stuck. Okay, let's look at others. Where's my book? Okay, so the sides of an equilateral triangle are increasing at a rate of such and such. A kite 100 feet above the ground moves horizontally. A car is traveling north on a straight road. So any preference, or I will choose?
$37.
37. 30. This one, the Boyle's law?
Yes.
Certain instant volume, the pressure. Yeah, well, that's fine. Let's try it. Okay, 37. And I'm on page 10. And the time here is still good. Okay, good. So is compressed at a constant temperature. So careful with this. So temperature is constant. The pressure P and volume V satisfy the equation. Okay, so P, V equals C, where C is the constant. Okay. Suppose that at a certain instant, the volume is, again, suppose that at a certain instant, that's a trap. So the volume equals 600 cubic centimeters. The pressure P equals 150 kilopascals. Okay, and the pressure is increasing at a rate of 20k kilopascals per minute. So what does this represent first? And then we'll come back. At what rate is the volume decreasing at that instant? We'll continue reading. So not yet. First, we have to identify what this is. 20 kilopascals per minute. What is this? We need to identify this number first. Anyone? Give it a try. Kilopascals per minute. So what could it be?
Is it
Derivative of pressure.
dP over dt. Awesome. Good. So let's go back and read it one more time. So we have the equation. We are given the function P times V equals C. Perfect. C is a constant. Keep that in mind. It could be 10, 15, it doesn't matter. Suppose that at a certain instant the volume is 600 centimeters cubed. The pressure is this, and the pressure is increasing at a rate of 20 kilopascals per minute. At what rate is the volume decreasing at this instant? So now the question is, what are we asked? At what rate is the volume and decreasing? We have to get a negative answer at this instant. So what are we asked to determine? Anyone? How fast is the volume decreasing at this instant? What do you think this is? What is the question or the problem asking us to find? Anyone would like to give it a try?
Yeah, dv dp.
Of course. dV dt, you mean? Awesome.
Yeah, dt.
Yes, awesome. That's what we are asked to do. Fine. So PV equals C. We differentiate both sides. I put a dot under functions. Obviously, P is a function of T. Obviously, V is a function of T. So can anyone help? I will help with the right-hand side. Can anyone help with the left-hand side? Differentiating the left-hand side. I'm ready. Anyone wants to try? P times V, knowing that both of them are functions of time. What do I write? Anyone? Can anyone tell us what rule we apply here?
Yeah, it's going to be the product rule. It's
Awesome.
P times dV dt.
Careful.
I mean.
Yes, it's okay. It's okay. It doesn't matter. So, but I want you to say, yes, you already said that. So you are differentiating the second one first. That's fine. So P dV over dt plus?
V times dP over dt.
That's it. Excellent. So we're asked to find this. So this is our problem. This is our question. We move this to the other side and divide by P. So dV over dt equals negative V dP over dt over P. Awesome. We have all the numbers. V equals 600, P equals 150, and dP over dt is given to us as 20. All we need to do is just plug in the numbers. V, 600. As expected, we get a negative number. dP over dt, 20, over P, which is 150. So one more time, V 600. This I just make sure that I plug that in correctly. Yes. So I will simplify, and I will simplify here by 4, right? So 60 divided by 15 is 4 with a 0. Okay, so this is negative 40, and then the measurement unit. Oh, 40 times 8 times 2, negative 80. Measurement unit.
Kilopascals.
Careful, we are talking about the dV over dt.
Centimeters cubed.
Per
minute.
Yes, it has to have 2 measurement units. So 80, 40 times 2. 40 times 2 with minus in front. Negative 80 cubic centimeters per minute. Awesome.